I've done something unholy, Chad. We've altered the trajectory of a cloud service provider, sort of, kind of. This might be the basis of the beginning of the ultimate Proxmox enterprise business use case installation configuration guide, because it's not just about Proxmox. Proxmox has Proxmox Datacenter Manager and Proxmox Backup Server, and you really need the triumvirate of those in order to get the most out of the virtualization platform. And if you're a VMware refugee, this is very important for you because you sort of will expect all these features, and if you just go to try Proxmox, it'll be like, there's not a lot of stuff here. I've got a small setup here with just 2 nodes. Really, you want 3 nodes for a cluster? Can't have a quorum if one of these are down. Quorum meaning that there's an agreement among the machines that remain up as to what to do. But look at this. I've got a virtual machine running on this. I can right-click, migrate that, and now it's running in the cloud. Oh, it's over here. Oh, it's over there. Feels like an Old Spice commercial, doesn't it? But what's in the cloud is running on my Proxmox Backup Server. I partnered with OpenMetal. OpenMetal.io, they provide bare metal hosting. And they actually have changed the way that they do service a little bit to make it a little bit more conducive to support hosting Proxmox on bare metal and building a Proxmox cluster. So in this video, I'm going to walk you through that setup on their configuration, but it basically applies anywhere. It doesn't necessarily apply to OpenMetal, but you can also learn about some of the other ideas here, including being able to host a hardware-accelerated virtualized router in the cloud, but also being able to seamlessly move virtual machines between your local infrastructure and the cloud infrastructure, and being able to sleep good at night knowing that all of your cloud infrastructure is backed up locally. You can sort of minimize costs. You can leverage bandwidth to differentially send only the parts that have changed from your cloud here to a local backup, and you can hit a button, push button restore from your local backup to your local infrastructure, should something catastrophic happen. So there's a lot of fun. Let's dive in before I get ahead of myself. All right, so this is our Proxmox cluster that is running at OpenMetal. I've got 5 machines configured on their control panel. I've got the first 4 set up. One of them is kind of set up as a storage server. For the tutorial, I'm going to start with a 3-node cluster, a very basic 3-node cluster. I've got high availability pfSense. That means 2 pfSense virtual machines running on 2 different hosts. Now this is not part of Proxmox's high availability. This is actually handled in the VM. So failover and all that. If one of the hosts goes down that contains my pfSense router, the host isn't going to, like Proxmox, the cluster itself is not going to do anything to try to get that VM running up somewhere else. OpenMetal also provides multiple VLANs. So we're able to follow the best practice to have a storage VLAN and a control VLAN for CoroSync on Proxmox. That's also definitely a best practice. Internal VM communication VLAN, as well as our internet-facing VLAN. So this is really cool. They also provide a bonded interface. This is a big competitive differentiator for OpenMetal, in my opinion. You have 2 10 gigabit connections from each machine, or at least the machines I selected have 2 10 gigabit connections in a bond. So if you lose one network connection, the thing will just keep right on trucking. And then running, whether you want to run it locally or run it in the cloud, is Proxmox Datacenter. This can run as a virtual machine, but this will interface with all of your instances of Proxmox and will facilitate moving virtual machines, migrating virtual machines from local to remote. There's a couple extra hoops you can jump through and actually set up ZFS replication so that you can have 15-minute replication from the cloud to your local machine, and this is a differential replication that is very inexpensive. Because we're using ZFS as our backing store, at least I plan to do that in the tutorial, ZFS automatically knows it's a big O1 computation. Basically that means there's no overhead to know what has changed from the last snapshot to the current snapshot. It's not like rsync or other technologies where it has to scan everything to see what changed to move it that you might be familiar with your backup software. The way that ZFS works, it has a journal. It knows what's changed from individual snapshots. So if you have a 10 terabyte VM in the cloud, but you're only changing 500 megabytes a day, the backup system will only send 500 megabytes, and figuring out which 500 megabytes is very computationally inexpensive, which is fantastic. And so our Proxmox Backup Server, you could run it in the cloud, that's fine, you can pay for those services, but I think it is maximization of resources if you instead use bandwidth. Unless your data set is churning constantly, you're generating, hundreds of gigabytes or terabytes of data a day, it doesn't make sense to run the backup in the cloud. You could just stream the backup from the cloud system to something locally. Now for this video, I'm assuming that you're familiar with networking concepts and you've installed Proxmox on like a test system or a homelab system, and you're a little familiar with the stuff there. There's also a longer guide. So I'm moving kind of fast in this video, and I sort of am assuming that you've been there, done that a little bit with this. If you need a little bit more hand-holding, definitely engage. And if you have ideas for more videos, or you would like to see more videos, engage, because the next video in this series is going to be dictated by you guys. So like, what do you want to see? What questions do you have about this setup? Do you, think there's a better way to do this, that, or the other? I'm using ZFS replication for nodes as opposed to Ceph for like a true hyper-converged, like drop-in vSAN replacement for those of you in the, that are VMware refugees. Welcome VMware refugees. And so that could be something, but let's dive in. Let's go step by step. Let's dive in. Let's look at the setup here, because it's going to be Proxmox on bare metal and what you have to do for that, the networking aspects of that, which are a little involved, and then storage and storage and networking. Like there's an advanced part of the networking. There's a little side mission you can go on. Storage, replication, Proxmox Backup Server. We talk a little bit about, okay, you want a VPN from your local resources to the remote resources, and Proxmox Datacenter Manager. And for time, one of the next things that I want to do is like maybe look at something like Uptime Kuma. Uptime Kuma is really amazing for monitoring all this infrastructure. You can deploy that as a container, very lightweight, basically no cost at all. You could deploy that. Well, you wouldn't want to deploy that on here, but you could deploy that as a standalone service on your Proxmox Backup Server. But that's coloring a little outside the lines, and we want this to be commercially supportable. We want the Proxmox support to not send me angry emails when they encounter things that I have suggested you do. Let's dive in. Now, when you get your account set up at OpenMetal, you'll have a backend like this. And we want to go to deploy servers. And in deploy servers, you want to pick bare metal. Now, in the deal I've set up with OpenMetal, should you choose to move forward, and again, they recommend you move forward in phases, a couple of machines at a time. If you commit to a 1-year term for the machines, the bare metal machines that you are buying, you're going to get half off whatever the monthly service fee is for the first 3 months. So you're committing to a year of monthly service, but you're going to get half off the first 3 months. And the details for that is below, so you want to check that out. Check out the forum thread. But you'll have something like this. And this is what you use to add to the cart and do your pre-configuration, upload your SSH key, that sort of thing. Now, there are a group of machines provisioned. I'm just going to pick 3 of these to start with, and we'll add a storage server later and then get creative with our 5th server. But you'll have your machines and their names and their public IP addresses will be listed there. And you'll have some information about your subnet. So when you click on the little ... you can do IPMI access. And this will work even when your machine is offline. This is out of band access. You can also use this to quickly, soft restart the machine. These are just shortcut calls to functions that are available in the IPMI. You can also go to details and see the details of the network interface. But we need to click on IPMI access to begin to set up Proxmox. I always like to choose the terminal installer just because it's text and it's fast. I mean, we're pulling an ISO file off of your computer. So if your internet connection kind of sucks, it's going to be a really just terrible, painful installation experience. Their connection's good. My connection's pretty good. We're rocking pretty good here. The terminal mode, all the way. Now, the networking part is specific to OpenMetal. I mean, well, okay, philosophically, we're going to talk about it, and it's not. But how you set that up where the rubber meets the road is a little OpenMetal specific. But the thing that you should know about Proxmox is that it has, ideally, multiple networks. And in the cluster, multiple networks give you the ability to sort of prioritize traffic and do sort of control. The most important network in a Proxmox cluster is the CoroSync network, or the sync network. And this doesn't have to be a fast network. I mean, I've deployed like 5 and 10 machine clusters that just use gigabit. Gigabit is fine for synchronization. Really, the latency matters more than anything, and it's just using control messages. And the latency is very important too, because if you're tempted to say, oh, well, let's put some machines in the cluster in the data center and some machines not in the data center, I would recommend that you don't do that. I've experimented with that. We can chat more about that on the Level 1 Techs forums, but definitely not something recommended. And if you're doing, you know, a 3, 4, 5 machine cluster, having them all be local is sort of important. And that network is also critically important because that's the network that the cluster decides if a member is up or not. So the way that that's implemented in OpenMetal are VLANs, and it gives you the VLAN ID in your network configuration tab on your specific machine. So I've spun up 5 machines here. OpenMetal has sort of let me spin up 5 machines. We're going to use 3 of them for our cluster initially, but it'll have the IP address and the VLAN and the gateway and the subnet and the net mask and the bond information. Their networking configuration by default is you get 2 physical connections to their top of rack switch, and that is how they provide the redundancy. And the VLAN is like your private VLAN in this leg of the facility. And then there's also bond options there, the transmit hash policy for layer 3 or 4 mode, 802.3 AD. MTU is up to 9,000, and so you can have some more VLANs that you add on. Now, for my configuration, I've got compute control, storage provider, and tunnel. That'll give me some flexibilities. That's 5 extra VLANs, but you'll notice it's from 694, 695, 96, 97, 99, and 98, 98 and 99. We will need to configure this in networking in Proxmox. So it doesn't really matter what you do for the initial setup in Proxmox. For my setup, it's setting up like NIC 0, NIC 1, NIC 2, NIC 3, which is very nice as compared to like the long ENP whatever. But you know, OpenMetal has their own walkthrough, and they walk you through. It's like, okay, here you can bind an IP address and set it on this, but this is not going to work on reboot. Like when this reboots, it's not going to be accessible on the internet. You're going to have to manually configure the network by updating this. And using the information that is established there. And their example here, you could use as a guide, substituting your IP address and your VLAN ID. That's what is here, bond 0.376. The VLAN, you know, they've got a comment here that explains this. If you're totally lost and confused, you know, support can help you, or you can hit us up in the forum and I can take a look at it, and that's fine. Another clever thing that they do in their guide is, you know, the machine that you bring up can do IP masquerading, networking, network address translation. And so it can take an internal network like 192.168 and translate it to the public internet. And so the one thing that I would tell you to do, I'm going to choose 192.168.100 instead of .2 for my configuration, because you know, I might have a local network that's 192.168.2, and I want to make sure that there's you know, no ambiguity as I connect those networks together, because I may have a VPN for like this office and another office and another office somewhere else, and that might be like 192.168.0.1.2, and then what's in the cloud here, my bare metal in the cloud, 192.168.100. So if I get my networking set up right, I could do ping 192.168.100.1, which might be one of my OpenMetal servers, and that'll work from one of my internal servers that's at 192.168.1.1. We're going to talk about Proxmox Datacenter Manager, which is another package, another fun thing that'll let you move virtual machines from your local clusters to the data center clusters, as long as you got the networking thing there. But I'm getting ahead of myself. So this is one way to approach this. You can also build a virtual machine that does the routing for you from this internal subnet, and that is connected to those VLANs, because those VLAN IDs apply to all of the machines that are in this group. And so your initial configuration, getting this thing back on the internet, you're going to have to set up the bond, which is bonding those 2 physical network interfaces to the top of rack, and then we're going to create some virtual interfaces off of that use the different VLANs. And for the cluster synchronization control, that's what we're going to use for CoroSync, and CoroSync will run over that, and we'll set some internal addresses for the CoroSync network as well. But for now, this is the written guide. This is the step. This is the most involved part. It helps if you can use the terminal, but I've got another trick up my sleeve. Now, you can always go to the tutorial, the documentation from OpenMetal, like the official way to do it. And you should do that. The documentation they did is great. However, it's a lot of steps and typing and like you configure in the terminal. So I created, and this is what's in the forum thread, an ISO that we can mount a script that'll make things a little easier. Go gadget networking. Yep. All right. And so this pulls an inventory of NICs. And so it sees NIC 1, 2, 3, 4. 3 and 4 are not, they don't have a link. So we'll say 1 and 2. 1, 2, because it's NIC 1, NIC 2, and that's the number 2 here. Because I didn't, I'm kind of lazy. I don't want to have to type out the interface name. Because sometimes it's those long, like ENP, like you just don't want to do that. Bond members are going to be NIC 1 and 2, NIC 1 and 2. That's the ones that I have a link. That's fine. What is the public IP of the server? We can flip over here and put in our public IP, just as it appears here. It'll also ask you for the subnet, and you can hit this handy copy to clipboard button, and it'll copy it to the clipboard, but the clipboard doesn't function because it's remote control. You can't paste because it's a terminal. You can't do it. What is the internal IP and subnet should be used for the VM? Okay, so this is where you can choose. And you should choose a subnet that you're not already using. It can be 10.10.10.10. You could do /16 for an ungodly number of IP addresses. You could do /23 for 512 IP addresses, like whatever. My default is 192.168.100.1 for the first system. Note that when you're setting these up, like I've got multiple systems to set up here. The first one will be 192.168.100.1, but the next one will be .2, the next one will be .3, and so on. We're on the internet. Google is responding. Look at that. We have networking. And now we can open a new tab in the browser and go to our public IP and pull up the Proxmox interface, which is why you hopefully set a very complicated password. Very complicated. Now I've logged into the Proxmox web GUI and we're ready to set up the cluster part of it almost. The next thing to do is to get updates and to make sure that we've got our license subscription thing configured. If you're not going to do the subscription, you can do the community version, or if you just want to do the trial. But again, I really would strongly recommend the actual Proxmox subscription. It is well worth it, and it is not terribly expensive, especially in this post-VMware world we find ourselves in, huh? Okay, once you get your updates applied from updates and your subscription set up, reboot again. Because you probably got a new kernel or other updates. I mean, it's hard to say. And when we create the cluster, we go to the data center. Like the data center is like the conglomeration, like the superset. And then Infallible Lizard is our machine, but we're going to go to cluster and set up. And then link, we will pick the CoroSync network and use that. And I'm just going to call the cluster name cluster. Now, in the guide from OpenMetal, which is quite good, they have you put in the public IP address here. And that maybe is a time saver later when you manually edit the interface file, but I think it makes more sense to set the CoroSync, the control network, the internal IP address. And so for this video and the how-to that I did, I'm just using 10.10.10.1, 2, and 3 for our 3-node cluster. And I think it makes more sense to put that in here because that'll go ahead and set up the name of the machine. And when we go to set up our cluster later, that's the IP address that's going to show in the UI. And now we can hit this join information button, which will give us an IP address and a fingerprint and join information. Now, the IP address here, it should not be the public IP address. It should be the 10.10.10.1 IP address, or the IP address that you chose for the first machine in the cluster. So I've got our other node here, our Courageous Piranha, and I'm going to go to cluster here, and we're going to do join cluster instead of create cluster. Now, one other thing that the script should do is make the default IP address of the system the CoroSync IP address. And that's important for the GUI parts of Proxmox to work correctly. I mean, you could use the public IP address, but we're not going to do that. That's not good. So if we go to, it says, it's the link that we picked, but it doesn't necessarily use that one. If we go to join information, we do see that it is our correct IP address, which is great. And so we'll be able to copy the join information and log into one of our other systems. So here I am on Courageous Piranha. I'm coming from Infallible Lizard, the machine named Infallible Lizard, to Courageous Piranha. And I go to Data Center, and I go to Cluster, and we go to Join Cluster this time instead of Create Cluster. And so peer IP address, remember we pinged this earlier. We should be able to put in the root password, and then we can choose the cluster network. It's like, boom, there we go. There's our link. The peer's link address is .2. All right, we're in Pedantic Cardinal. Going our third machine to the cluster. Now, if you've gone 4, 5, 6, 7 machines, join them to the cluster. Now, let's go back to our machine that we started with. Hey, we can see our 3 machines, Pedantic Cardinals coming online. There it is, boom. So we have 3 nodes. That is awesome. Now we can set up storage. Okay, with the cluster set up, before we configure our storage, the next most important thing for you to think about before we get to the storage part is the networking part. Because right now, the 3 nodes in our cluster, they do have a public IP address, and there are bad guys on the internet that are scanning for open ports and they're scanning for connectivity. And so here I'm inside our interfaces file, or networking interfaces, et cetera, networking interfaces we covered before, and I've uncommented the network address translation lines. This is going to let you use the firewall that is built into Proxmox. And that is fine. That is a reasonable strategy. There is documentation for that from Proxmox. You can keep it running this way, and that's completely fine. You can also build a virtual machine or 2 to do your routing, and that opens up some more possibilities we'll talk about in a minute. But you really do want to minimize the surface area that is exposed to the internet through these machines. Minimally, I would say, like, if you're connecting to these machines, you know, like the IP address you're coming from is a fixed IP address and it doesn't change, then set up firewall rules in your network interfaces file to only permit traffic on the Proxmox port 8006 and SSH from your trusted IP address. That's a really easy, low-hanging fruit thing to do. There's some, I mean, we've covered how to do that in the Level 1 Text forums and in other guides. There's tons of guides on the internet to do that, but you really want to secure and lock down your stuff. Generally, like, depending on what you're doing, you probably don't need any real just, you know, unchecked inbound traffic from the internet coming into your system, unless that's part of your use case. Like, oh, we are using the cluster to host services on the internet for customers. We have to accept web traffic and SSL. Those are things you could set up and do traffic forwarding here in the interface, or build a virtual machine for routing, which I'll show some cool stuff you can do with that. But now we need to set up storage and virtual machines in order to be able to do that, because this is just our machines, is just a cluster. We gotta have somewhere to put the virtual machines. It's not, you know, the boot volume. No, we've used the boot volume, we've created this, but we haven't used the other local disks that are in the machines that I've provisioned at OpenMetal. So you can click on an individual machine in the cluster, go to disks, ZFS. We want to do create ZFS. We can select the unused disks here. You can choose which RAID Z level you want, or what level of redundancy. RAID Z gives you 1 disk's worth of capacity as redundancy. 2 gives you 2 disks, and so on. If this is your first foray, I'm so sorry, we're going so fast. You're gonna have to check in the forum and get it to slow down a little bit. But we want to create a volume here, and I just called it tank, and I'm gonna call it tank across all of the nodes, because once it's created, we will want to do that on all of the nodes. So our tank volume here is this. Now, by default, it's going to store virtual machine images and container images, and it'll show up here underneath the virtual machines in the cluster. And so you can see I've got VM disks and CT volumes. I've already created a VM, and you can see that tank is listed under each one of these. You can have a cluster member that doesn't have local storage. You wouldn't be able to migrate, in that case, or set up automatic replication or whatever. And the ZFS part is important, so that we've got the ZFS mechanism for replication. So the thing that you store on here will show up in the left when you click on it. And so, like, this volume will store VM disks and container volumes, CT volumes. The CT's lightweight containerization, VM is full virtualization. I'm assuming that you're, remember, you're a little bit familiar with Proxmox. And it is a good idea. I mean, you can create, ZFS subvolumes or files, like ZFS datasets that are tuned for the specific thing that you want to do. Like, if you do have a database virtual machine that you want to run, it behooves you to figure out how big the disk operations are by default in your database system, and create a ZFS volume that is, roughly corresponds to that. So, like, maybe 128K or 256K, or maybe even 64K at the ZFS level. For larger VMs, you can use a larger record size, but it's just balancing the performance versus ZFS feature set. Because ZFS does add a fair bit of overhead, but these are also large instances from OpenMetal, so they've got a lot of CPU horsepower. Okay, with our virtual machine online, there's not really much left to do except install Ubuntu. Now, I'm setting up the desktop version, but If you're using server, it would be the command line version. So, ta-da, we have our first virtual machine. Well, as soon as it's done installing, we could go and create virtual machine 101, 102, 103 exactly the same way, increment the IP address, it'll be able to get on the internet the same way. All of those will be sharing in behind the public IP that is the default gateway, or whichever machine you elect to use as the gateway if you enable NAT on more than one of your hosts. And this will work fine. This is a perfectly reasonable strategy. But I would also strongly encourage you to take steps to lock this down so that you can't just, try to log in or log into your Proxmox cluster using a public address. If you come from VMware, this is like leaving your ESXi, just sort of naked on the internet. You don't want to do that. And I figure that some of you will be hankering for more steps. There is a full guide for that on the Level 1 forum. Let's set up a router as a virtual machine with some high availability. I'm going to stop short of recommending this, especially if this is new territory for you, because there are some trade-offs. But what we can do is create a virtual machine to handle the ingress from the internet. And that gives us a lot more flexibility than is in the GUI with Proxmox. You can still use the firewall tools in Proxmox, like that's still a good thing to isolate one virtual machine from another, because the network design is not really, like in the olden days, it was like you had a big honking firewall that would protect all the stuff, and then behind the firewall, things were a lot more open. And some network security people have described that as like, oh, it's like let's get the hard shell, but then you get the delicious caramel nougat center. And you really want your security posture inside the network to be almost as hard, if not as hard, as what is on the internet side. And so you will still use firewall tools in Proxmox, ideally, even if you have another separate firewall solution somewhere else. And you could do bare metal firewall, but I think that's a waste of resources. We can just set it up here and be good to go. So let's do that next, or at least let me show you that. And then there's a quick version, and then there's a full run through on the forum. See, you're getting some ideas for engagement challenge. What do you want to see in follow-up videos? Like, what would be useful to you in terms of setup, Q&A, for like the perfect Proxmox setup in the cloud? Now, because this is already hosted on ZFS, I don't want to do ZFS within ZFS. We're going to use UFS. And PFSense will install, and we'll be ready to configure it. We can just go to the IP address in the browser. It doesn't need a special port or anything, just HTTPS 192.168.100.254. You can accept the warning and continue. That's like next, and it's like hostname. We'll call it pfsense1. The domain name is fine. But what we can also do is set up a replication task. And so I'm going to add a replication task to this, and I'm going to say, hey, replicate this from Pedantic Cardinal, which it's on now, to Courageous Piranha. And I can set the schedule for that every hour, every day, whatever makes sense. Think about the use case of like a web server. How often are people uploading files to the web server? Are the files that people upload to the web server in a different place than the application that actually runs the website? If the application that runs the website doesn't change all that frequently, then you can maybe replicate that every day and choose a different storage mechanism for the files that people upload. Or maybe people do upload files and those are stored locally. And so it's like, okay, Monday to Friday, 7 a.m. to 18:45 every 15 minutes, or every 30 minutes, or every 2 hours, or whatever. And you can enter, */15, and it'll be every 15 minutes, or */5, and it'll be every 5 minutes. I wouldn't recommend more often than every 15 minutes, but that's even pushing it a little bit. I'm just going to do every 30 minutes. You can also rate limit it. So if you've got a bunch of these going with replication, you can say this is going to go no faster than this many megabytes per second. You're on a 10 gigabit connection, guaranteed, and OpenMetal, and so that means you can do 1 gigabyte per second or 1,000 megabytes per second, guaranteed. And so you can do some mental math and figure that out. I'm not gonna set a limit. You can also set a comment for the replication. You can also create the replication but not enable it. I'm just gonna go ahead and create it, and I'm also gonna tell it to go ahead and run now. Now that we've set up replication, which took 12 seconds, because it's a fresh install, there's not really a lot going on here. If we do migrate, it's like, oh, it might take a long time because we're migrating to Courageous Piranha. But because the target is Courageous Piranha, we already have replication set up. So it only has to replicate the 8 gigabytes of memory or 16 gigabytes of memory or whatever you configured on this virtual machine. So I'm going to do migration here, and you can see that it's creating a snapshot. It's doing the migration, and It's like, oh, we're doing all this. Just about in the time it takes me to explain what it's doing, it's done. If you've ever used rsync, for example, it's like I need to rsync this from the source to the destination. And the destination already has most of the stuff. Rsync just goes through, figures out what's changed, and copies it over. But it has to do a lot of work to figure out what's changed. ZFS, with the way that it's designed, automatically knows what has changed. So when you have replication and you're using ZFS, ZFS will automatically know from the source system to the destination system what it needs to go look at in order to copy. Like that's an O1 operation basically to copy, figure out what changed since the last snapshot or the last migration, whether that's 30 minutes ago, an hour ago, or a week ago, and actually just move what's changed. So it goes very fast. And that's what we did here. And now we can see that our system is running on a different host. And if we click into our new host and we click to the virtual machine and we go to the console, we can see it's still on the internet. It's still able to get through. It is getting through the internet through the pfSense virtual machine that is running on the other node. But, you know, that happens seamlessly. That works seamlessly. Now, let's talk about in the data center, in the high availability thing here, you can create rules. And you can say, I want this VM to be highly available. And so it will try to restart it and relocate the machine and fall back. And there's a lot of really interesting stuff in the Proxmox documentation. A little outside the scope for this video, but this, like, you know the terminology now, you know how it's supposed to work, you know what that's all about. And you can also create a comment here. And so you create the high availability rule, and as long as you have a quorum, that means that you have at least 2 of your 3 nodes in our 3-node cluster, or 3 of 5 nodes in a 5-node cluster, or whatever, that it will make decisions based on what the rules here are. You also have fencing and affinity rules, and these are generic cluster and high availability terms. Sometimes you get industry specific terms, especially if you're coming from like the VMware side of things. But you can create affinity rules that say, hey, these machines will migrate this way or this will migrate this way. This can be especially important if you're using SRIOV for networking or VDI for video sharing. It's not really super applicable to the OpenMetal side unless you go for the gold star and you enable SRIOV. Our hosts here do have the Intel X710 NIC that supports SRIOV, and in the guide that I wrote on the Level 1 forum, I wrote a script to help you enable the X710 virtual functions, which you can then assign to virtual machines. If you look at Courageous Piranha, our public IP address on VMBR0 is a certain thing, and that's where our default gateway is. We've got 192.168.100.1, and there is no default gateway set for that. But we could theoretically set a default gateway of 192.168.100.254 now, because we have the virtual machine that's a router that is using another different public IP address, and traffic that comes in on that interface could go out on that interface. Proxmox doesn't do that or permit that out of the box, even though it's perfectly fine to do that with Linux. It does open up some oddball edge case security concerns, but if I were to do 192.168.100.254 here, so it's like traffic from the internet can appear on this network, and if something from the internet is talking to me, then I should respond through this. Like this server, think about this from the server's perspective. It has a public IP, so if something comes in, it's like, oh, I should respond to that. It'll just respond from its IP. But the receiving system, it's like, wait a minute, I asked for something on this IP. This other IP is responding to me, this other public IP that's different, because our 254 has a different public IP address than the other one. And so the far end, the receiving system is just going to discard the packet because it doesn't seem to be related because it's coming from a different IP address. This is actually a security problem. And if I just do this, it's like, oh, there's already a default gateway on VMBR0. Now, I was trying to add a default gateway on VMBR1. Technically speaking, there is nothing wrong with that, but this is not a thing that works really well. And this also, like, trying to do this kind of stuff creates like a nightmare scenario for OpenMetal to try to have to support this. So you have to use your big brain to understand how this works, and so supporting this can be very hard. And I think it's kind of dumb to have these machines set up in that way, because each of these machines with a public IP plus also access to this internal VM LAN has created a kind of a large security surface area. So really, let's think about this in terms of transitioning from your Proxmox hosts not needing a public IP address of their own to the virtual machine configuration on the pfSense side of things. So if we go on pfSense and we configure destination port 8006 on the WAN address should go to 192.168.100.1 8006. If you just try that in this configuration, it is not going to work because 192.168.100.1 Courageous Piranha is going to respond directly from its public address, and that's not going to work. That's not a valid thing. But what we can do is log into our cluster. So I'm logged into our cluster actually through Pedantic Cardinal's public IP address. But you know, from Pedantic Cardinal, this Proxmox interface will give me access to Courageous Piranha. And I've removed the public IP address and the gateway, and I hit OK. Now, if I had SSH access to this or anything like that, I would lose that as soon as I apply this configuration. But what I'm also going to do, and this is another cool feature of Proxmox, is before I apply that configuration, because until I click apply, it's not going to happen. I'm going to edit this, and I'm going to add my default gateway through 254. So let's see if I can get to our Proxmox cluster now through pfSense, through the NAT configuration that I did. I am now connected through pfSense with NAT IP address forwarding, which you may be familiar with, to our Proxmox cluster, and Courageous Piranha is no longer on the public internet. I mean, the interface is physically on the public internet, but it doesn't have an IP address on the public internet, and so our surface area for attacks has gone down tremendously. In pfSense, I can set up a rule, such as my source IP address. I can use pfSense as a VPN gateway, so that I'm only allowed to connect through a VPN, IPsec, OpenVPN. I can also set up Tailscale. I can make this part of the Tailnet, and then, you know, Tailscale can run on pfSense. Tailscale could also run as its own separate VM. Tailscale could be installed on all three hosts. This is also a little more fragile now, because previously all three of our machines could get on the public internet directly because they have the interface to do so. And it is possible to configure that up as a secondary or a backup interface, but that is a little outside the scope of this video, and you can definitely hit me up in the forum if that sounds interesting, because you do have to make some fundamental low-level networking configuration changes so that the Linux is told basically when something comes in on this interface, send it back out over the same interface. Then you can have multiple default gateways, multiple ways to get on the internet in a way that is kind of sane and makes sense. But from a security posture standpoint, I don't actually like that. And so even though this is a little more fragile, I like the idea of running both of our pfSense machines on two different hosts, and with pfSense on two different hosts and the high availability there, that's pretty good. That's pretty good in terms of reliability and failover and all that kind of thing. And this is all on just bare metal. And I've also not really wasted any resources. The full brunt of the substantial resources that I have here, you know, I've got a terabyte of memory in one of these systems, and the other two have 512 gigabytes of memory. This is some serious hardware. And I'm using that for routing, and I'm using that for virtual machines, and I'm using that for a lot of cool stuff, potentially. And I've also got really good failover, really good replication, and really good network architecture, even though it's just three machines. Works out really well. Proxmox Datacenter Manager I've set up as a virtual machine on the cluster. I've got a local cluster and a remote cluster. We haven't talked about my local cluster yet. You kind of saw it when we were setting up Proxmox Backup Server, but we'll get to that. I'm using the root account to log in and generate a token, which it will do automatically, and it will also automatically accept the fingerprint. So it's a little more sophisticated than the Proxmox Backup Server. And then once I've done that, it says that it can reach all remotes and that all three nodes are online. That is fantastic. Proxmox Datacenter Manager could run locally, especially if you have a VPN where it can connect to the internal IP addresses of all of those. We also want to add the Proxmox Backup Server as a remote as well. When we add another cluster to this, we can use Proxmox Datacenter Manager to replicate and migrate VMs between clusters. So at the beginning of the video, I mentioned it's like, well, you know, you wouldn't want to stretch the cluster into local and remote. It's not really designed for that. But what you can do is add your local cluster to the Proxmox Datacenter Manager, whether that's running locally or remotely. And then you can use Proxmox Datacenter Manager to manage replication and migration of virtual machines. If you have a mission critical virtual machine that you really don't want to have to run locally. You'd rather it run in the cloud with its nice, high availability, engineered data center stuff, whereas, your local ISPs just barely able to keep it together. But you still would like to have, every 15 minutes or every 30-minute replication for those mission critical systems that are running in the cloud on bare metal at OpenMetal. Then you can use Proxmox Datacenter Manager to set that up and do migrations of VMs and replication. So if you wanted to temporarily bring everything down because you are reconfiguring something in the cloud, you could do that. You can set that up through Proxmox Datacenter Manager. Now the networking part and the routing for the internet and making sure that DNS is updated for internet inbound stuff, that's a whole other thing to worry about. Again, a little beyond the scope of this video, but Proxmox Datacenter Manager, I think, flies under the radar of a lot of people that otherwise use Proxmox, because it's like, oh, we can actually migrate virtual machines from clusters automatically. I mean, I know there are shell scripts out there to do that. There's probably, I vaguely recall writing some of those on the Level 1 forum years ago, but Proxmox Datacenter Manager is a much better way to do that. So check that out and use that with Proxmox, and yeah, it's a tremendous tool for managing your fleet. Now, it might be tempting to go to Data Center and Ceph and install Ceph. Ceph is an alternative storage thing. It's clustered storage, and Ceph is very good. But Ceph is not really something I recommend with a relatively small number of nodes. It can be done if you have 3 nodes, but really the only good option with 3 nodes is that you've got full replication on all 3 nodes. And fortunately, OpenMetal has a lot of Ceph expertise. Their support will be glad to help you if you need help planning a Ceph cluster. So if you're going to do something complicated with Ceph, reach out to them, talk to them, and help them plan, because you have to think about what your I/O workload looks like. And if you're, if you've got a lot of database servers, it's going to be a very different situation than if you have, a lot of web servers, or if you have other different kinds of machines, what the I/O workload looks like. And in preparing for this video, I've sort of expected, it's like, oh, maybe Ceph would make sense. And it might make sense for like a 5 or a 7 node cluster. It might make more sense. But I think for 3 nodes, ZFS replication, as we have it, where you can make decisions about whether or not you need replication and how much replication you need on a machine by machine basis, makes more sense than installing Ceph on a cluster like this. But, I'm happy to engage. This might be a deeper conversation for the forum or another different video some other day. Now, I just want to do a really quick clip for Proxmox Backup Server. It's super easy to install on bare metal. And like I say, I'm running it on the Beelink ME Pro, which is a NAS that's based on the Intel N95 processor, one of the most anemic processors you can get in 2026. It's 4 cores, but it can do ZFS duplication. It's got 2 mechanical hard drive bays. It's got 27 terabytes of local storage. I don't know if I would really... you're going to be limited to about 250 megabytes per second as a practical matter for restores. You need a good backup appliance. But when you get it set up, there's a web GUI for that, and you can browse it, and you can use a lot of stuff with it. Now, it supports tape backups. You can back up to S3. You can replicate to S3. You can do traffic control. You can set up notifications. You get really awesome email notices. There's lots of really cool features. And this comes with your Proxmox Enterprise subscription. But when you set it up in your data center, or how you set it up in your data center, this is my OpenMetal cluster here, and we've got all of our machines on the side. In data center under storage, I've added PBS offsite. And so this is reaching through the VPN at OpenMetal to that little machine that's sitting on my desk in the studio. So it's coming over the cloud, and because it's differential backup, we're using bandwidth, and I have all my stuff that's running in OpenMetal synchronized to this appliance, which is fantastic. And then for the, a virtual machine that we set up in the backup tab, it populates the backup tab. And you have flexibility. You can say, okay, I want to store a couple backups locally. This is my local storage. This is actually the boot volume. If I wanted to, I could add my ZFS volume here. But PBS offsite will show up here, and then it will show all the points in time, going back a week or whatever my retention policy is. Then I can click on a thing. I can do file restore. And when I do file restore, it is reaching over the VPN to the storage on our Proxmox backup server, and then I can even do file level restore interactively as I'm doing here. It's got a lot of other cool features, but Proxmox backup server really closes the loop on a lot of features that people are looking for, and it is that easy to set up. So there you go. Thanks to OpenMetal for sponsoring this video. If you want to get in, I actually have some discount codes and stuff that you can use below that is also linked in the forum. Definitely please use those and tell them that you heard about me through the link in the integration. Like I said, now is the winter of our discontent in terms of RAM prices. And depending on the cloud provider that you're looking at, I mean, by all means, do comparison shopping, whatever else. But if you really do the math and you look at it, you might be able to just coast this RAM drought for another year or two. Or maybe it makes sense to have all of your customer-facing stuff and important stuff in the cloud, but you set up that ZFS replication to come back here. Now, this is only the tip of the iceberg. There's a lot of other questions that I'm sure that you want to dive into. Now, the deal from OpenMetal that I managed to set up is you get half off 3 months of service if you sign up for a 1-year term. So if you're going to sign up for one server or multiple servers, whatever your service fee is, you get half off for the first 3 months, but it's a 1-year commitment and you pay monthly. I would love to hear from you about your projects on the forum. So that's enough rambling for this one. Thanks again to OpenMetal for sponsoring this video, maybe the first of a couple of videos, depending on how you guys engage and what sort of content you want to see. I'm Wendell, this is Level 1. You can find me in the Level 1 forum. Let's discuss how you're scaling up and scaling out your Proxmox stuff.